Hello, everyone. Today, we're going to take a look at the way to handle or manage custom certificates in TKG or the clusters which are provisioned through Cluster API. There are several benefits of actually handling the lifecycle or actually trusting the custom certificates in TKG clusters. So obviously, to secure the communication between the components which reside external to the cluster itself, the compliance is because there are companies which need custom CAs to be used in all their clusters, not the publicly trusted certificates. And it also provides us a better control because as an administrator, I can go ahead and trust the certificate and also revoke a certificate if I don't trust that external entity anymore. Essentially, to handle the entire life cycle of trusting or deleting a particular certificate in TKG clusters. So increased trust because, as explained, we do have to make use of custom certificates to ensure there is a secure communication between TKG and the other components or the clusters provisioned through Cluster API. And cost effective because considering there are multiple domains and subdomains in any given organization. So actually affording a public CAs or the certificates which are signed by public CAs, trusted by public CAs, would be a little expensive. So in those cases, it's really cost effective for us to handle custom certificate. And the classic case of custom registry usage, which is our use case mostly, wherein we would have to trust a registry which is an internal registry which is provisioned through a custom certificate. And to achieve this, there are two objects we are going to interact with. One is Kubernetes config template and the machine deployment. If you actually take a look at the standard documentation for the existing clusters and for the new clusters, the two ways of doing it. One is to actually create this overlay and place this in a particular path where your Tanzu binary exists, or your gem box, which you can actually interact with for provisioning of clusters in the future. Right. This is for the new clusters. The second way of doing it is to the existing clusters to get the certificates which are there, which needs to be trusted, and actually manipulate this Kubernetes config template object and a machine deployment as well in order to trust the certificates. The problem with this is, let's say we have several machine deployments for any given cluster, and let's say I have 20 clusters, and I have to manipulate. I have to manipulate around 3 Kubernetes config and machine deployment per cluster. That would take me to almost 60 objects plus the machine deployment to actually manipulate and change, which is actually a real pain for us to manage and to handle this at scale. So in that case, what we have done is to develop a utility which will take care of the life cycle of these certificates. And this utility not only helps you in managing the day 1, day 0, provisioning new clusters, but it'll also trusting certificates into new clusters, but also helps you in managing day 1 and day 2 as well, wherein you can add new certificates to the existing clusters and revoke them or delete the existing certificates as well. So this piece of code and binary is available in GitHub. If you want to take a look, you can go ahead. If you look at the code itself, it's pretty straightforward, and it's a flat structure. I don't have any directories or subdirectories wherein different files are placed. Since it's a simple program, it's just a flat structure. So all I'm doing here is there are the different methods wherein I'm interacting with a Kubernetes cluster or a TKG cluster, a management cluster, to manipulate these objects. To manipulate these objects, I've also defined the types, which are here. So let's not look into the control plane currently. So these are the two types which I'm interacting with. One would be the Kuberium config template object. The other one would be the machine deployment. To do this, I am actually getting the Kuberium config template list object. I'm getting the list of them in the sense I'm just grabbing the name of the objects which exists, and then appending the custom certificate in it. I didn't want it to use client go here because it abstracts a lot of things which is handled underneath using the client go. So I've used plain HTTP method using the plain old HTTP client so that this program can be coded in any other language that needs to be, which you would like to use, so that you would be exposed to all these endpoints and interact with the Kubernetes cluster, essentially. And this is to look at the actual classic use case, what we actually go through most of the time. So I have this a Harbor registry, which is not yet trusted by the Kubernetes cluster or TKGM cluster in our case. When I try to pull the images from this particular registry, I wouldn't be able to do that. For instance, if you look at the environment itself, I have three clusters here. One is the management cluster, the shared services, and the workload cluster. Currently, I am in management cluster context. If I have to go to workload cluster and say, I would have to pull this particular image. Okay, I don't have this Kubernetes utility. But these are all the namespaces what I have in workload cluster. If I have to run, I am in a default namespace here. So let me just go ahead and delete this particular pod. All right, so I don't have anything running here. So let's say I would have to pull the image from the Harbor. So let's say I'll have to pull the Alpine image. Let me just log into this. So if I have to pull this image just for this demo, I will run this as a plain pod once I get access to the CLI. So I would say I would pull this image from this Harbor, and I would also have this image pull policy just for this use case. And if you look at the pod, obviously I wouldn't be able to pull this image because we can take a look at the events, and it clearly says fail to pull the image because the certificate is signed by unknown authority. The certificate is not trusted, which clearly means the certificate is not trusted by this cluster. So in order for me to trust the certificate, and also there is other use case as well for future provisioning of the cluster, we will have to place the certificate in this path, or this path. To trust this certificate, let me go back to the management cluster context. So right now I'm in management cluster. If you actually take a look at so these are the Kubernetes config templates objects what we have, and I can also take a look at I can just describe them and take a look how the object looks. So essentially what we have to do is to actually append. This is a list of this files parameter as a custom struct or a list of custom object, and that object, there is one more object that we need to create with the certificate, owner, path, and the permissions. So if you actually look at the spec under Kubernetes config template, we have something called as files here, which is a list of a custom object, which needs content, nothing but the certificate, the owner, the path, and the permissions to be added to this. So in order to do that, we can make use of this small program called a CCLC manager, MGR, which will actually handle the certificates lifecycle very gracefully. This utility also provides us ability to actually pull the certificates from a server as long as we provide the host name for it. So to run this utility, we can also take a look at the machines. Before machines, we'll take a look at the machine deployment. So these are the two different machine deployments what we have. So machine deployment is the machines to machine deployment is equivalent to the pods to the deployment in Kubernetes cluster. So these are the machines what we have. They're all in running state in both the clusters, the shared services and the workload cluster. And it's equivalent to the pod in the deployment, right? So the machines are handled by the deployment. So the machine deployments are declaratively defined, and it represents the desired state of the machines. So if the desired state is not achieved, it will go ahead and reprovision and try to match the current state with the desired state. So what we'll have to do is to actually manipulate this particular Kubernetes config template object and then patch this machine deployment object. So if you look at the what I'm doing here is this particular program can also handle the deletion of the certificates or revoking the already existing certificates in the TKG or clusters, or the clusters which are provisioned through cluster API. So I'm appending the certificates here, but I can also handle the deletion as well. Once we either append or delete, we will have to patch the machine deployment object. So all I'm doing is to get the current time, and I'm just patching the state, annotating this particular machine deployment object or every machine deployment object which we pulled with the current time and date, right? And To run this, we already have, if you look at it, we already have the FQDN of Harbor. So to run the CCLT, the utility which will handle the certificate, all I have to do is to CMGR, and the action would be append. All right, and the server. So what do I need to do here is to append the certificates to the trust store, to the existing TKG cluster, or trust the certificates in the existing TKG cluster. To do so, I'm just going to supply the FQDN of Harbor. So it's the program is still in its raw form, but actually, if you see what it did was to go ahead, pull the certificates from the Harbor, right, and then pull the Kubernetes config template object, and then change it, append the certificate, and then push it back, right? Edit the Kubernetes config template and push it back, in the sense patch the same changes, and then also patch the machine deployment object as well. So if you look at, these are the two machine deployments I'm handling, and these are the, I'm currently patching it with the current date and time, right? So if you take a look at, I think I have it in history. If you take a look at the old Kubernetes config and the new one, this is the new certificate that's been added, the custom certificate with this permissions and the path, with the below owner path and the permissions. And if you take it, the machine deployment, and if we describe this or take a look at this, you can see there is there'll be a date which is the current date, which is actually pinned to this, right? Wednesday, February 15th. So, and finally, we'll take a look at the machines. Right, you should see them being provisioned or in the deletion state. If you look at this, these are the two machines which are deleting right now, right? So then they will be provisioned and new machines will be deployed. So once the deletion is handled, you can see there's a new, all right. So if you can actually see the actions or recent tasks which are executed in a vSphere, you can see that there is a deletion of the machine, and there is also a provision of new machines as well. Right? If you look at this, if you look at this power on virtual machine, in the sense we are reconfiguring, we're adding a new machine, and we are provisioning new machine to this cluster. And it will take some time, since this is a nested cluster. It's going to take quite a while for us to actually provision these machines, post which we should actually have this we should actually have this certificates trusted in the cluster. If you see, let's take here. No, these are the one is in deleting and one is in provisioning state. But at the same time, you can see it's already cloning a new VM template and provisioning a new VM as well. So let's give it some time and come back and see if we can pull this Alpine image that we tried earlier, which was throwing us a 509 unknown certificate authority error message. Hello, everyone. Welcome back. So now if we look at the state of the machines, we see all the machines, all the three machines are provisioned and in the running state, right? And it will also go through a certain deletion if the current cluster state does not actually match the desired state, right? Through machine deployment. So if you look at all of this, if you actually take a look at the tasks here, what's happening, the recent events, we just saw one of the virtual machines powered off, and it went through a deletion as well. And to see the state, now it's in the deletion, but that would also happen to the workload cluster if there are more than 3 worker nodes. But here we see it's already done. So we have 3 worker nodes and 1 control plane node. And if you also actually take a look at the nodes within the workload cluster context, let's go to workload cluster. We are currently in the management cluster to manipulate the kubeadm and kube machine deployment. And I'm going to go to workload cluster to run these images, right? And if you take a look at the number of nodes, here are the nodes. And if you look at the age, which were recently provisioned 6 minutes ago, 14 minutes ago, or 21 minutes ago. But this won't change the control plane node, which continues to exist. And we are not changing a kubeadm control plane template here. We're just dealing with kubeadm config plane template object. And so now we will go ahead and try to pull the image or run the one which we had issues with. So there are no resources in the default namespace right now. And let me try to run the same command what we ran earlier to pull the image and run it. Right. I'm just pulling this image from this harbor Alpine image and trying to run it with image pull policy of always. Okay. So if you see now, it's in the container creating state, the Alpine image, and it's in completed status now. If you actually look at, if you describe this particular pod, if you look at the pod, it ran successfully, of course, but before that, it was also able to pull this image from this harbor. By doing so, we trusted this particular registry on our TKG clusters in shared services and the workload cluster. And it also needs one more activity of placing the certificates in this particular directory. And so we would be placing it in 03 customizations folder, right? Because we want this to be applied to all the clusters for future provisioning. So right now what we saw was actually for the clusters which already are running. We'll also take a look at the future case right now. So let's go to this is where we need to provision those files. So if you look at this, this steps requires for us to place this YDT overlay in this directory and also place the certificate. So what our program did was to actually create this YDT overlay. If you look at right, so this is the overlay which we created, and also it created it pulled the certificate and placed this certificate in this folder as well. Right, so there's a certificate, there's a harbor certificate which we pulled earlier, and we did the same changes to Kubernetes config template object, and we also placed it here for future provisioning. So since now we are able to pull the images from the harbor and the machines are reconfigured and redeployed, that ends this activity and the session. Have a good day. Thank you.